Hello, everyone. Thank you for joining us today. I'm Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's webcast. We would like to begin today's program by saying a big thank you to Dell for sponsoring today's event and let you all know Foglight APM Software as a Service Edition gives you eye-opening visibility into your web and mobile application so you can react quickly and improve constantly. With lightweight, always-on collectors, you'll capture every transaction every time. Plus, analytics-driven diagnostics from a big data repository allow you to transform big data into big answers. For more information, visit www.foglight.com. Our speakers today are Max Firtman and Steve Fox, and they are going to be talking to you about becoming a mobile application performance genius. Max is the founder of IT Master Professional Training and has authored books including Programming the Mobile Web and jQuery Mobile Up and Running. He is a frequent speaker at QCon, OzCon, Breaking Development, Velocity Conference, Fluent, Google Developer Day, Nokia Developer Days, Campus Party Europe, and other prominent conferences. Max has received the Nokia Developer Champion Award every year since 2006, as well as the title of Adobe Community Champion in 2011 and recognition from Google. Steve Fox is Product Manager for Dell Foglight, with a specific focus on end-user monitoring, mobile, and analytics. Steve has more than 20 years of industry experience across aerospace, telecommunications, search, natural language, and intelligent monitoring technology spaces. He has held positions as a software engineer, system consultant, entrepreneur, and product manager. Steve holds a BS degree in electrical engineering from the University of Texas at Arlington. Folks, I'll turn the program over to Max in just a moment, but first I'd like to go over a little housekeeping to help you get the most out of today's webcast. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Max and Steve. We find that our audiences usually have a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Max and Steve, please preface them with a capital letter Q so we know that they're for them and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is VelocityConf, all one word. If you have any trouble with the webcast, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. We would like to let you know that we are recording today's webcast and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Max to begin the webcast. Hello, Max.
Hi, Jasmina. How are you?
Thank you.
Well, fine. Perfect. So let's start, guys. So my name, as Jasmina was saying, is Maximiliano. You can call me Max. That's fine. I'm a mobile web developer. I have been doing mobile development since 2001 and web development since 1997, right? So I'm also training. I have been working with all the native platforms, also with web platforms. So I'm also doing trainings on Java for Android and Objective-C for iOS and right now Swift. So I have written some books, right, as Jasmina was saying, Programming the Mobile Web and jQuery Mobile Up and Running, both from O'Reilly Media, of course, and also with some translations on different languages, so you will find a lot of translations out there. But as you know, I'm not here to talk about my books or myself. We're here to talk about your apps. So basically, if you have an app right now, and I am going to define an app in a minute, but let's say that any kind of mobile app, right, including even mobile websites. So if you have an app, you might have a problem right now. a big problem with your users. Maybe you're even losing users. So the question is, why is that? Well, there are two situations here. First, most of your users are right now probably angry with you, right? And the other situation or the other feeling here is that some of your users are really frustrated. So that's the other issue that we have here, right? So, and that leads to some specific problems, right, with your app, but not just with your app, with your company, because today your app is your company. So that's why this is really important. Performance is really important when we are talking about the mobile world. So usually what is the biggest problem is that mobile apps, let's say by default, are slow. So they have a performance issue, right? We have a really, really performance problem when we are talking about mobile. So in the next few minutes, I will try to explain you the biggest issues that we have right now when we're talking about apps, how to start thinking about this to find finally a solution. So performance is the big thing here, right? It's the word that you need to understand. It should be your first top priority, right? Sometimes when you have things like UI design, yeah, of course, it's very important to have the UI design or marketing in the App Store. But if you have a performance problem, you have a bigger issue. And that's something that you need to attend right now. So after this webinar, you need to go there and try to start measuring your app and start creating new experiences for your users. So now let me define what an app means right now, because usually there are different concepts out there. But from our point of view, I'm talking about the mobile space. And when talking about the mobile space, we have websites, right, on one end with, of course, HTML5 for mobile devices. We're talking about the browser, a URL. And we also have apps. From a user's perspective, an app is something that is installed with an icon in the home screen or in the applications menu, and it might work offline. It depends on the app, but it might work offline. The user is not really opening a browser to access our app. And in the apps category, we have different kind of apps. We have native apps or fully native apps that are for Android, iOS, Windows Phone, and maybe other platforms as well. You know, you're using the Android SDK and you're using the iOS SDK on a Mac to create native apps. There are also other hybrid solutions in the middle. We have web apps, and usually a web app is when you are installing a website in your home screen, and that website becomes a web app in full screen mode outside of the browser. And finally, we have native web apps. These native web apps are, for example, PhoneGap apps that you are creating using Apache Cordova, PhoneGap, or any other framework that are basically using the web view. So on all of these situations, you might have a performance problem. And the important part here is that performance issues are on each kind of apps. So one of the interesting data that we have right now is that 35% of the whole web traffic or internet traffic right now comes from mobile apps. That's a lot of data, right, coming just from mobile apps. And that means that sometimes you are using, or let's say spending budget on performance on the web, and that's perfect, right? You should also do something with the web, but you are not really understanding that you might have also performance problems on the mobile side. And those problems are sometimes even bigger than on the web. And from a recent research and a recent study from one university at London, so 9 of 10 users uninstalled apps because of performance problems. So think about yourself as a user. How many times did you download an app? The app was really slow, it wasn't working at all, or was taking too much time. Finally, you uninstall the app. In fact, you can go right now to any app store and find any app and look at the reviews and try to find negative reviews. Most of the negative reviews are because of performance, okay? So it's something that we need to attend. And another data that is coming from these reports is, for example, that 3 of 10 users, or 30% of the users, would pay more money for a faster app. Okay, so that means that if your app is slow, maybe the user is going to somewhere else, even with a competitor that is charging more money than you for the same service. So there are 30% of the users willing to pay more for a faster solution. So that's why it's so important. And finally, Dr. Chris Brower, right, from this research, said that users experience a lot of negative emotions and frustrations when trying to complete some digital task. Apps or web page are slow to load. So when apps or web pages are slow to load, we have frustration and negative emotions over our app. And remember, today our app is our company. So that's why it's important. But we're talking about performance and being fast or being slow. We are usually talking about response times, or at least let's talk about the perception of these response times. So based on an old in terms of digital computing, right? Because it's on 1993. Jacob Nielsen is one of the gurus of usability. He found 3 main time limits, right, based on human perception. That 3 time responses that we need to attend, and 2 of those 3 time limits applies to mobile websites and mobile apps. And these 2 things are, first, 100 milliseconds. So when a user is feeling that a reaction is instantaneously, right, that we are directly manipulating the UI, is when we are sending a feedback to the user in less than 100 milliseconds, okay? So a tenth of a second. That's basically our first threshold that we need to achieve. So every feedback, right, should be up to 100 milliseconds. But sometimes you need more time, right, because you need to go to a server, and in that case, the second threshold is when we are talking about the user flow of thoughts, okay? And in this case, you should be as fast as possible, right? But usually the threshold is around 1 second. So that means that after a second, the user is thinking on something else. So you need to understand that, right? So after 1 second, the user, remember we are users, right? So humans, we as users are thinking on something else. So what are the biggest problems that are not letting us working with these particular thresholds? Remember, 100 milliseconds and from 1 to 1,000 milliseconds. That's for the user's flow of thoughts. So, meaning that why sometimes a task is happening in more than 1 second. So the biggest problems are usually on some small parts here. The first part is launch time. So we should, because of this flow of thoughts, right, the launch time, that means when the user is opening the app, right, we should show something on the screen in less than 1 second. Can we achieve that? Yes. If you are doing something really, we are using too much CPU, for example, or if you are going to the network when the user is launching the app, maybe you need to distract the user. And I will give you some ideas in a minute, right? So the user is seeing something in 1 second, because if your app is taking more than 1 second, our brain starts to think on something else. And that means that sometimes we are getting out of the app. I'm pressing the home button, I am going somewhere else because, I remember I need to order a pizza, right? And then the user is out of your app, and maybe you're losing money because of that. So that's why launch time should always be in the 1 second threshold. The next big problem, and I'm pretty sure you understand this, is CPU, right? So we know that in terms of power, right now we have better mobile devices as maybe a year ago or 2 years ago. But even now, CPU are roughly 5 times slower than on desktop. Okay, I'm talking here about usually what happens on average devices. Because let's be honest here, the web community, the mobile developer community, we are not average users, and we are not right now using the average device out there. We need to understand that the real world is different than our world. So, and that's usually important when you're testing, for example, right? Sometimes we are testing on our own devices, and that's not enough, mostly for performance. The next problem in terms of performance is in the memory side. Okay, so in the memory side, we need to. Usually when we're talking about memory, we have something around the garbage collector. Okay, so the garbage collector is a process that is running with our app and is keeping memory, right, let's say, in line. Okay, and usually that's the biggest problem we have. Okay, so we are using too much memory, and the garbage collector needs to clean the memory all the time. So you need to understand this problem and try to solve it. Modern tools will help you working with this and trying to find your problems, your memory problems on when the garbage collector is being executed, so you can solve that problem. So usually when talking about performance, we have the CPU, we have the memory, and finally, we have the network. So, and this is a big issue here. So, most of the apps, okay, not all the apps, but most of the apps are going to the network. Even for advertisement, even if it's an offline game, maybe you're sending data to social networks. So all the apps are really using the network. Okay, I'm talking about the network with the round-trip time to a server. I'm sending a request to a server, and I need the answer, maybe because I'm showing something on the screen, or I'm waiting for a response, or I'm posting something. Okay, so, and I'm pretty sure that some of you at this point are thinking that we shouldn't care about performance anymore because we have 4G. And that's a big problem, thinking in this way. First, not everybody is on 4G. And let me give you some real data. Today, right, October 2014, only 4% globally, 4% of the users are in 4G, right, worldwide. Of course, as you can see in the chart, in the United States, that the market share of 4G is bigger, it's around 29, 30%, okay? But on globally, it's just 4%. So it's just really, it's not really so important right now. Hopefully, in the next few years, we're going to see 4G getting bigger and bigger. But even when we are talking about 4G, and this data comes from the US market, 30% of the time, 4G was not used. So you have a 4G phone, you have a 4G data plan, but 4G, 30% of the time, is not working. And you see that on your own phone, right? But even let's say that everybody's in 4G, that you know that is not true. But let's say that for a minute. So when we are thinking about 4G, usually we are thinking about the bandwidth, okay? So as you can see in this chart, you have different bandwidths in 2G, 3G, 4G, and Wi-Fi in average. So on 4G, you can get up to 7.5 megabits per second. So yeah, it's fast. But my question is, how important is this when we're using a mobile app? Because the mobile app or a mobile website is just sending requests to a server and usually receiving small answers, unless you are, you are playing video in streaming, or you are YouTube or something like that, where when you are really downloading big files, you are just download usually small XML files or JSON files or text files. Okay, so the bandwidth is not really important, and the biggest problem that we have there is not the bandwidth, right? It's something called latency. And this is the round-trip time. So the latency is the time that happens after you send the request and the time that happens until you get the response from that request. And if you look at this chart, you will see that even in 4G, okay, it's around a quarter of the second, the maximum. So it can take up to 250 milliseconds of nothing because the latency is there for nothing. We are not really receiving data. So after the latency, the data comes. So, and maybe you can say, okay, just 250 milliseconds. But if you compare that, for example, with the home connection in the US, right, you will see that it's usually 5 times bigger. The latency is 5 times bigger in 4G, just 4% of the users worldwide. And when you go to 3G, it's nearly, roughly, up to half a second. And in 2G, it can be 1 second. Okay? And here we have a big problem. And I'm pretty sure that some of you are already aware of this problem, but some others are listening of this problem for the first time. Okay? So that is something that we really need to pay attention. And the most important thing here is we need to measure this. We need a way to see this on the real world with real networks, right? Not just with your provider, with providers on different cities, different states, different countries, different continents. It's different everywhere. And of course, we can't solve the latency, but we can work with it, right? So if we know that we have a latency on one particular situation, we can try to do something around that, right? We can try to make an illusion for the user or try to keep the user engaged with something else. So that's why testing on the real world is really important. And remember that bandwidth is not so important, right? The most important part here is the latency when we are talking about mobile app traffic on the network. And today, let me say that most of the performance problems out there on apps, not every problem, but most of the problems are because of the network. The latency, and that you are not really understanding that problem and trying to offer the user a better experience somehow. So when we are talking about testing, the real world is different than you might think. You are not the real world, right? Your phone is not the real world. So pay attention about that. Do you know when and where right now you are slow? Where do you have the problems? Maybe it's in one web service that you have that is taking too much time besides the latency. And maybe you're using a spinner or a loading, and the user patience has a limit. And that's why maybe the user is saying that you have a performance problem, and that's maybe why the user is uninstalling your app. And the worst thing that can happen here is the user going to the store and putting you a bad review. So how to improve this? First, we can't improve what we can't measure. So the first important thing is that we need to measure, right? So there are ways that here in this, after my presentation, you will see a great tool for this. You need to measure so you can learn where and when are you having performance problems. The other tips that I can give you right now are, for example, trying to be a magician, and that means working with perception. Okay, so don't let the user think that your app is slow. And there are some tricks to do this. For example, one way is to be optimistic. That means we assume that it will work. For example, Facebook is using this idea, or Pinterest, or Instagram. So, for example, when you like something, the server is not waiting for the answer to giving you the idea that it was liked. Okay, so in the UI, it likes automatically. And then, of course, you can, if there is a problem, you can inform the user that it didn't work or something like that, but be optimistic. That's the first tip. The other tip that seems really weird, right, is to avoid the usage of spinners. And that's weird, and this is based on a real research. You have the link there. So the research says that spinners doesn't distract the user. If you put a spinner, it's because you are slow. So you are using a sign saying, I'm slow, please wait. Okay, of course that there are some specific situations where spinner will go, but if you have a really small delay of 1-2 seconds, you shouldn't use a spinner. There are different examples of this. So this you can use, for example, a skeleton screen or animations that might take 1 or 2 seconds, and in the meantime you are downloading the data. And this particular research comes from this app, Polar, that was acquired by Google, by the way. So in this case, they're using a skeleton, the one you're seeing on the screen right now. So while they are downloading the data, instead of using a spinner, they're just showing you the skeleton, okay? And with the spinner, the same app, okay, the same app with the same performance measurements, with the spinner, had a worse review. So in terms of the users complaining about performance, the same app without the spinner, people says that the app is faster without the spinner. The same app, right? So we are tricking the user. And if you're a Facebook user, I'm pretty sure that you recognize that Facebook on the web, I'm talking about the web in this case, Facebook on the web is also using this idea of a skeleton. And there is a little animation while a post is loading instead of a spinner. So this is much better, right? So just to wrap up things here in terms of mobile app performance, we should right now, and when I'm saying right now, I'm saying in the next hour, right? Go and stop users' frustration and anger, right? Because people are frustrated because of your app or your app of your website. Performance is number one issue. Remember, the feedback, every feedback should be in less than 100 milliseconds and the maximum in 1 second. Okay, so no more than 1 second. I mean, if something is taking more than 1 second, people will complain. So try to do something to trick the user, to change the perception of your app. Latency is a big problem, so learn to measure and do something about that, right? And also, besides the latency, is the time that your server is taking to answer. And measure a lot, and change user perception. So that's all. So thank you. By the way, there will be Q&A later, so I will now give the power to Steve.
Thanks, Max. Some very interesting data. First saw Max speak at Velocity Santa Clara, and for some of the same data, and it's interesting how it's a more technically challenging environment, but the user perception requirements are actually higher. So he's absolutely right. You really need to pay attention to these kind of things if you're going to have a successful mobile app. So before we get into my section, there's a couple of polls I wanted to go through. We have a good audience here, and it's always interesting to kind of see where people are with different perceptions. So let me put up the first one, which is I'm going to focus on two main areas of what Max covered, the testing and the actual performance after it's deployed. So the first one has to do with mobile performance testing. So let me get this up. And just take a second to scan through those and see which one of those most directly applies to your organization. All right. So very interesting. Hopefully everybody can see that. Yes. So, and this is very common. We're seeing this across our customer base. It's very difficult sometimes to get the proper amount of testing done. But when you are doing it, you're typically doing it only on the simulator. It's very difficult to kind of get into that real world situation. So let me get back to the slides. And why is it? Well, the reason that you're having those kinds of results, and it's common, is it's very expensive and it's very hard to do this well. And it's mainly caused by the fact that the permutations that you need to test to do it effectively, they grow exponentially. So you end up with all these different device types. So, you have to build a lab and test on all these different devices because they have different performance characteristics. But the really big challenge, as Max pointed out, is the network. What about signal strength, the carrier, the different network type, what's the latency? All those factors start to come in, and the number of test cases just grows exponentially. And if you're really trying to do good coverage, you end up with a Q&A team that's walking around town looking something like this. So it's not cost effective. So the reality is, once you deploy your app, they're going to be exercising many untested permutations. And as Max pointed out, that is the area where we see the most trouble as far as performance. So the next poll then is, how closely are you watching after you deploy? Let me throw up a second poll. And give you a couple of answers to look through there. Whether you're doing synthetics, you have custom monitoring in the app, which means you've built something into the code yourself, or you're using some sort of third-party APM solution. And here are the results for those. Now, that's interesting. So I think the most comical line I saw from Velocity New York was the guy talking about healthcare.gov. And he said the only monitoring that they had in place at the time was CNN. They had no monitoring, so they would watch the news when people were complaining. And unfortunately, that's the state of practice right now in the mobile app world, is when people start complaining, we start looking into it. But obviously, that's a little too slow for where we want to be. Okay. So what is mobile app performance monitoring? This is where we shift after testing. We're in production. It's actually deployed. Real users are using it. And we need visibility into how the app is working for those real users. So we can see and respond to these incidents before they start getting so bad that people are uninstalling the app and giving us negative performance reviews being posted. So Foglight has been doing monitoring for a long time, and we just announced at Velocity New York a mobile APM solution to attack this problem directly. And I'm going to spend the rest of the time talking about how we approach this problem so you can see how that works. Before I dive into the details and look at specifics on product, I wanted to back up just a little bit and talk about what were our design premises. When we looked at this, we looked at a lot of the same data that Max presented. A lot of the stuff from Nielsen is very informative. And when you really start taking a look at it, one of the things that pops up is that latency and that network component to it. So we came up after much analysis with 4 major design premises. The first one is that this has to be easy to use. You can't put all the burden back on the developer, else it's just, you never get it deployed. So our first goal was minimal developer effort. We're trying to say 3 minutes or less to instrument an app, and you got to auto-detect as much as possible. If you want to come along later and add something, that's fine, but the base amount of value should come very quickly. And the second has to do with the majority of what Max was talking about. It has been our experience that the variability of the app making those HTTP requests back to the server is the most common performance issue of apps. There are other cases. It can be doing something that's CPU related, but those typically get caught either by the developer or in normal QA testing. So they tend to not happen as often in the field. The third design premise we came up with was there is the case where maybe the user does something different, they request an odd product, it wasn't captured. There are still cases where it is the back end. So we want to make it easy that we can flow through and see what's happening on the back end if that's where the problem tends to be. And the fourth is a little less obvious, but it'll become more apparent as we go through here. Just because an app is making HTTP requests, it's not always immediately apparent kind of what the app was doing there. So the concept of the app screen, or what was the user looking at the time, is a much more meaningful grouping mechanism because it's closer to the user experience. one screen might make 5 different requests. Any one of them could slow down the perception, or maybe only one does. Because, as Max pointed out, you did a good design to say we can get that first one there quick and keep their interest going while we load the slower things. Or it might be the one you're waiting on that's the most. But you have to look at it from the user's point of view if you're going to have good data to diagnose with. Okay, so now let me get into the architecture of how we approach this problem. It's similar, and it's what you'd probably come to if you did a detailed analysis of this. So the app's different than a browser. Okay, so the only way to do meaningful measurement of what's going on there is you have to be there with the app. So we developed an SDK which gives you a library that you can link into your application. It will collect the data as the user's running the app and sends that data off to our APM SaaS that's hosted in the cloud. Then we correlate it with any information that you have on your backend. You can instrument your backend servers, the ones that are servicing the requests, and we pull that data together so when you log into your account, you can see a consolidated view of where was the time spent on the front end, where was the time spent on the back end, and it helps you with your diagnosis. Okay, so now I'm going to go through each of these 4 areas in a little more detail. So first, the developer effort. So it's real simple to get started. All you need to do is sign up for an account on Foglight.com. When you go in, you download the SDK. We support iOS and Android, whichever one you pick. You add that framework or jar file into your project. Add a couple of lines of initialization code in either your app delegate or on Create, depending on your platform. Build and run your app. We're going to start collecting data. You can log in to your account and start seeing what you're seeing. Then as you get comfortable with where that stands, you push that out through the App Store. Data will be collected. Very simple to get started. So the second area is talking about this variability of app requests. So for iOS, we'll automatically detect, you won't have to do any code changes, anything that makes requests to the Foundation framework and the AF Networking 2.0 framework. So in practice, that's the majority of calls that apps are making. Unless you're writing your own HTTP connections, we usually will pick up every request that's made. For Android, we support those 4, which are the common ones used on Android to make requests out of the app. Get all this just by linking in that one library. So for each one of these requests, we're going to track a number of different things, but the most important things were the things that Max was talking about. What network type are you on? What is the signal strength of this request? The location, the carrier that it's coming across, the URL, and then the performance times. So I know this may be a little bit hard to see, but we can take all that data and make the nice Gantt chart waterfall charts that we're used to seeing from like a synthetic tool. So we can actually see the different requests that were made, how long they took, and what was the impact over the entire session that they had in the app. So now for the third case. So if you do have a case where the user's done something or they're requesting some product maybe that's an older product out of stock, some data-driven thing where the back end could be the issue, we want to be able to go quickly to there. So looking at that same screen I had up before, we can just go through and click on one of these longer ones to say, what's going on here? And we can get to the back end to say, here's the back end execution of what happened for that request, where the time was spent spent in the database, what method of Java was being called. You have access to all that type of information. And now let's get to the fourth one, which I think is actually the most interesting. So as we go through and look at the typical design of what an app does, it's very common that it's not just one HTTP request being made. Often makes very many. And often it's one user action can create many requests just to get one screen load done. Depends on your design, of course. So as Max was pointing out, background HTTP requests have a much less perceived issues than the ones that are blocking a screen load. So by looking at those and seeing on the waterfall, what are the ones that cause the screen to not appear, you can really focus your attention, and it helps keep you closer to the user experience. So we auto-detect the app screen changes as the app goes through, and we group the different HTTP requests that we see by app screen so that you can focus your attention on how is the user perceiving this. So here's an example of what that would look like. So this is a view controller that loaded. You can see it took 5 seconds to do so. There was a couple of simultaneous HTTP requests, but then there was a repetitive request to the same URL that happened another 4 times, spaced out over time. So this is highly suspect because whatever it was blocking. And so the user was blocked because the view controller could not release control and go forwards. So this would be some code to definitely go take a look at to see why is this happening, because this is not a good experience for the user. So now that you know the details of what we collect, the next big question is, well, how do we find the interesting things to look at? You have a lot of data flowing here. So we spent a lot of time looking at the analytics for how do we look at the interesting things. And so we leveraged our existing monitoring background and tried to bring this dynamic interactive analysis technique to light here. So here I'm just showing an example of different things that you can analyze, and you can see the HTTP requests, and you can break them out by URL, by the app screen, and geography. And then you can zero in on where those might be. Here's another example that I like to look at, like back-end time versus front-end time. It's a very common way to see where is the slowdown occurring. So anything along this line is basically the limit that it was a back-end execution time. So the things that start to go above this line, you start to wonder, why is it taking so much longer, and how much of that is network related? So that's what you get for the 3 minutes of tying into your code. If you do want more data, you do have the ability of doing it. So these are some of the more advanced options that we support. You can do crash detection and reporting, because a crashing app is worse than a poor performing app. You can also exclude certain URLs from tracking if you want. Maybe there's just either privacy issues or performance issues. I just don't want to track these. You have that ability to do so. And you can also customize your app screen start-stop measure points if you don't like the defaults that we've picked. Or you can time specific things, like maybe inside one view controller, there's a particular action where you do something and you want to get very specific timings. You can do that. You can also record error messages, popped up error messages, this happened. And you can record even handled exceptions if you want, something that the app handled gracefully, but you want to understand how often is that happening and what are the conditions that that's happening in. So with that, let me try to pull up the product live, and I'll show you some of these screens live, and then we can go to questions. Okay, pushing. Okay, so it looks like that's live now. So here's an example of like a health landing page that once we have the app instrumented, we build out for you. And it gives you an overview of the health of the application and how many requests that are coming in are good, fair, poor, or erroring out. We also show geographically how this is going. So like here it's showing that Canada is having a little bit slower performance than the U.S. and particular states are doing better than others. So I'm going to jump over and show you a live example of the one I was showing in screenshot. Hopefully you can see a little bit better in this one. So this is that front end versus back end tracking the overall response time against the back end. So all of these that come above the line become suspect to me. So I could just click on one of these, select them, and start analyzing what was the network type. And sure enough, just as we'd expect, the vast majority of them came in on a slow network, HSDPA, which is the 3G technology. So I can zero in on those, and I can see the view controllers that were most affected. Looks like it was this one. And I can go in and look now in more detail. See if I can resize this to make it a little easier. So this is the kind of information that we can get. We get the version, the carrier, the CPU architecture, all this we pick up for free, even the screen size. Then when we look at it from a session point of view, you can see all the requests that are made. And if one of these is taking too long, I can drill in and look at the actual request. How much of it was network time versus back-end time. Let me go show a different analysis. Let's do this one by OS. You could create any of these different analyses you want. It's just a different arrangement of different tiles. These are just a few that I've put together for example. So for instance, maybe we want to do an analysis and focus our attention in on iOS. So I could select iOS, and the operating systems will now show only the iOS ones. I can see that the vast majority of requests coming in off of this one is iOS 7.1.2. And here's the response time over time. I can start looking at individual view controllers if I'm interested, or want to just look at the ones that are slowest. Let's go look at this release notes one. This shows an interesting pattern here. There's definitely clusters of response times going on here. And it's across different versions of the OS. But there's definitely a pattern here. So this is taking up to 6 seconds. So I'm very interested to see what's going on with this set of requests. So now I can go explore the details of these. And let's go look at the front end. Here's the session. So this is a typical, you see a lot of requests being made spread out over time. And this is across the whole session. So what's much more useful is to look at it into the bite-sized user chunks. What were the different view controllers they were going through? So here we can see, the settings view controller was very quick. But some of the other view controllers took a long time and had multiple requests. So this gives us the ability of going in, zeroing in, and finding out where in the code we're having trouble and when it's network related especially. So we can focus our attention. Why do we need to make these 5 requests? Can we bundle these together and change the server interaction to just make this as one so that we're not paying that latency hit that Max talked about over and over? So that's all I have to talk about today. We can switch over to the Q&A. The last thing I'll say is this is available under beta currently at www.foglight.com, and definitely welcome you giving it a try and giving us your feedback. So I guess now we'll shift over to Q&A.
Thank you so much, Steve and Max. We have a lot of good questions that have come in from attendees. And just to let folks know, folks, if you do have a question for Steve and Max and what they've been talking to you about and showing you, open your group chat widget. It's that brown icon in your widget tray. Type your question in, send it in, and we will take as many as we have time for. And with that, Steve and Max, are you able to see the questions?
I am. I'm looking through them right now. Okay, so there's one question about, won't this code be overhead to my app, thus making it slower? All right, that's a very good question. So it definitely could, because as shown on the diagram, we are making a network call as well. So we took great care in how do we design this, though. So for one thing, it's never done at a point where the user is waiting. So we're collecting data on the device, and then after the screen is shown and the network has quiesced, we make our request at that point. So in effect, it's not affecting your user response time at all. It will add an extra call, so I guess there is a small amount of data that's passed along, but from a performance point of view, it should not make it slower.
So let's see, Shamina, can you hear me now?
We can hear you.
Perfect. So I have a couple of questions here. Great question, by the way. So so I said that 25% of the internet traffic right now is coming from mobile apps, and the question is if that 25% includes Netflix apps. So well, it's about the whole traffic. So yes, but anyway, even including Netflix, remember that you have Netflix on the desktop too. So basically, it's the same thing. I mean, it's not like the number will be different if we remove Netflix from there. It also includes YouTube, right? Then I have a question from Tyler. When I said 3 of 10 users would pay more for a faster app, what is the price point that users are willing to spend? Well, that's an interesting question. In this case, this is coming from a report that, by the way, the report is online. And that report says that was basically a kind of a survey. Okay, so it wasn't really talking about the real price, but people were willing to pay more. 30% of the users were willing to pay more if they are if the app is faster. Okay, so that was basically the only thing there. In terms of your question, so the price point is really a tough question. Right now, it's a business model question, and there are different business models here. More than the 99 cents price point right now, maybe working with advertisement is also a good idea. Then I have David, what is the third threshold, and why isn't it relevant for mobile apps? So I was mentioning 3 thresholds that were defined by Jacob Nielsen. One is 100 milliseconds, the other one is 1 second, and the third one is 10 minutes. And it's talking about the dialogue. So it was prepared for desktop apps. And the idea is, I don't know, if you are using a desktop app to do something, do some task, and that's the dialogue. So you should, I mean, the whole task should not be more than 10 minutes. But in mobile, 10 minutes it's like a year, right? So you are not using, unless it's a game, you are not using an app for more than 10 minutes usually. Okay, so for doing a task. So your task should be maybe 1 minute, not 10 minutes. That's why it's not so interesting on mobile. And let's say I have another one here. See if I can suggest resources to get reliable web stats. Yes, I can. There are, unfortunately, there are too many resources that you can use. Okay, so if you can ask this on Twitter, FIRT, my Twitter, I can give you some links. But anyway, Akamai, for example, akamai.io, they have a resource where you can find information. Netstat has also another resource where you can find stats on the mobile web. And finally, I can suggest you MOBR, M-O-B-R. You can just Google that. It's a mobile overview report. It's from last month, I guess, from the Ciencia Mobile guys. So it's a report where you can see the current stats on the mobile web. And now, Steve, if you want to.
I see another one that's kind of related too. Do you know if apps are being used more frequently via service provider networks, 4G, 3G, 2G, or via home Wi-Fi networks? I don't have any specific data on that myself, but at least from the customer base we've been working with, the performance issues tend to happen on the service provider networks, not over a home Wi-Fi, because you're now at regular network speeds that you're used to from your desktop. Where they're being used, I believe it's a mix, but I think it's pretty heavily used on service provider networks, at least just from my own experience. I'm out on the go a lot, but there is a blend in Wi-Fi. But our experience has been that you tend to have more performance issues for the reasons that Max laid out, is the latency goes up as soon as you get out of the house, and even if you're on 4G. Let's see, there's another one that's, I believe, kind of related. I'll say most of the discussion here has been around dealing with network-related issues, or the ways to find and identify performance issues not involving network issues, such as accessing a local database that can vary in size. Yes, so as I mentioned, one of our design premises is we believe that the majority of problems for performance are network-related. That's what the data shows, but it can happen for other things. So like the case where I mentioned it was the back end. As far as the case where it's something on the front end but it's not network related, we do give you some information. We're not going to dive into the details of we're not doing code profiling on the client because we don't want to slow it down, to the other point earlier. But you can get some very good clues, so you can still use the custom timing information. If you know there's a very potentially expensive query that you're going to do to a local database, you can actually time that, and we will capture that timing as you specified in the code and send it back. So you can say, okay, 90% of my users are making that query in 500 milliseconds or less. So you could collect that data to help you do the diagnosis that way. Okay, so here's another one. Do I have to include any message to inform the user about APM? To my knowledge, I don't believe you have to, but that'd be a question to take up with your legal team. It's a lot, depends. Mobile's such a different world. The majority of apps out there are making calls. They're either doing some sort of analytics, with Flurry or Google Analytics, or there's APM tools out there, and I've seen very few statements to that effect. In some parts of the world, you have to be sensitive to that, though, so that'd be something to run through legal. But my understanding is, because the fact that it's talking to your servers, that the users already knows that I'm trying to get information from eBay, so of course I'm sending information to eBay. Let's see if there's any others. You see any others in your queue, Max, while I look?
No, I think, cover all the ones I have here.
Okay, we're getting close to the end. Let me see if I can find one more. Okay, so you said that Foglight does the instrumentation to your code and links it in via lib or an SDK. That's correct. How much code does it add? What is the footprint in RAM and or local storage? I don't have the specific values, but we could try to get that information to you, or you could contact me directly at one of the links shown here, and I can get that information for you. It is very lightweight. It's typically a very small percentage of code, and as far as what's in RAM, all we're basically doing is storing information about the timings of things. So it's a very small relative to what you're typically talking about with even just images. And we just buffer that up until we have a chance to send it as one burst back in. So it's just a running queue that's quite lightweight. We haven't seen that be an issue. But send me an email and I will get that information to you. And with that, we're approaching the top of the hour, so to respect everybody's time, I think we will close. Thank you very much.
Thank you so much, Max and Steve, for presenting an incredible webcast for us all today and for sharing your knowledge and expertise, gentlemen. All right, and folks that attended today, we thank you for attending our webcast today, and we had people from all over the world, so we thank those of you that stayed up late and got up early to attend our webcast today. Many of you are asking about a recording. Yes, we are recording the webcast today. We will have the recording ready within 48 hours, and we will send you all an email as soon as it's ready with access details, and you can watch it and share it with your friends and colleagues. And folks, as we do close out, we would like to say a big thank you to Dell for sponsoring our webcast today and let you all know Foglight APM SaaS Edition gives you eye-opening visibility into your web and mobile application so you can react quickly and improve constantly. With lightweight, always-on collectors, you'll capture every transaction every time. Plus, analytics-driven diagnostics from a big data repository allow you to transform big data into big answers. For more information, visit www.foglight.com. Thank you again, Dell. Folks, this will conclude today's webcast. Goodbye, everybody.
Conference recording has stopped.